First, we'll revise topics from the syllabus and then we'll do paper 2. We completed the first 6 topics. The last one was energetics. Now, chemical reaction. Identify the physical and chemical changes and understand the difference between them. For physical change, like example, melting, boiling, evaporating, these are the physical changes. Chemical change, in which a new substance is formed, and even you can write a equation for that. So this topic is related mainly with the rate of the reaction or speed of the reaction. So the concept that rate of the reaction is proportional to number of the effective collision. According to collision theory, like if particles have energy more than activation or equal to activation and they collide with each other, it will lead to a formation of a product which we also call a successful collision. So speed of the reaction is affected by concentration. Concentration means amount of the number of the particle. Increasing the concentration will increase the rate of reaction, but amount of product, whether amount of product will change or not, that depends on which concentration is changed. Like example, if we have a reaction in which acid is reacting with metal, and that is giving us salt plus hydrogen. So acid plus metal result in a formation of salt and hydrogen. Acids are aqueous, metal in a solid state, salt is also aqueous, and hydrogen in a gas. So when this reaction occurs, we'll observe fizz, bubbles, effervescence. If I am using excess of the metal more than enough and I am using a limiting reagent as an acid. So say 2 grams of metal was reacting with 1 mole per dm cube of concentration of acid, which was a limiting reagent. And we plot a graph for volume of hydrogen gas in time. So in the beginning 0, steeper slope means fastest rate, and as the number of the particle decrease, rate decrease. Eventually the rate is 0, it means that the reaction stops. So if I change the amount of the excess reagent, like example, first I was using 2 grams, now I'm using 4 grams. So this changing the amount of excess reagent will only affect the rate of the reaction, but the final product will remain unchanged, or it will remain same. So rate will increase, but the amount of the product will not change. But if we increase the concentration, or if we double the concentration of limiting reagent, then what will happen, it will affect the rate as well as the final amount of product. So when you're sketching a graph, or sometime the original graph is given, and according to original graph you have to sketch another graph with a change in concentration or change in amount of limiting or excess. So if in a question limiting reagent is changed, how we will know which reagent is limiting and which one is in excess? Either it will be given in the question, or you can use the moles to identify which one is limiting and which one is in excess. Using a mole ratio, the amounts which are given, use a mole ratio, you can work out limiting and excess reagent. But normally these type of question in which you have to sketch a graph, they give you the information that which reagent is limiting and which one is in excess. Rate of reaction is also affected by the particle size, large surface area, small particle. When we have like powdered form, then small particle size, they have a large surface area, so more effective collision, greater the rate of reaction. Catalysts, the substance which alter the rate of the reaction without chemically consume, or they lower the activation energy so that reaction can proceed at a lower activation energy. So if we have a reaction, endothermic reaction example, reactants have low energy and the product is having high energy. And the minimum possible energy at which the reaction starts, that is called activation. But if you use a catalyst, catalysts provide an alternative route for the reaction to proceed, or they lower the activation energy. So lower activation energy, the reaction can go on. So this one is without catalyst, the first one, and the lower one is with catalyst. And what are enzymes? Enzymes are basically biological catalysts, and their working depends on, in biology you have studied that the working of enzymes depends on the temperature. As temperature changes, temperature increase, it changes the shape of the molecule, or it denatures the enzyme, or it is also pH effective as well, like at certain pH it is effective. But you're not going in detail of pH, effect of pH on a working of enzyme. The only part which you have to know about enzymes here, which are biological catalysts, and only the reaction which you have studied, that is fermentation, manufacture of an ethanol by, or alcohol by fermentation, in which we use about 30 degrees. If the temperature is too high, it will denature the enzyme and the reaction will eventually stop or slow down. Increasing a temperature, how increasing a temperature affect the rate of the reaction? Increasing a temperature increase the kinetic energy, so molecule move faster, and it will increase if a collision frequency, number of molecules will collide, as well as most of the molecule or greater proportion of the molecule will have energy more than activation energy, so the reaction can proceed. So hydrochloric acid, this is a simple experiment. You will find commonly it is repeated. Sometimes in a conical flask we have this mixture. We add hydrochloric acid with sodium thiosulfate. It will form a sulfur. That sulfur, which is a solid, it will block the light, so we are not able to see a cross which is under this beaker. So we record the time taken by cross to disappear. If it will disappear in a shorter time, because the rate and time interval, if a reaction proceed in a short time, it means it is having the fastest rate. So by changing the amount of different reagents, chemicals, we can work out how it is affected by, how it is affecting the rate. The product of this reaction, when sodium thiosulfate is reacting with hydrochloric acid, gives sodium chloride, and sulfur molecule is also there. And that sulfur will make the solution cloudy. Why the height of the container is important? Because what happens if you are using a two flask, say 100 cm cube flask you are using, so if, for example, if I'm using a 100 cm cube flask, means maximum volume it can hold is 100 cm cube, and we added, like example, 60 cm cube of a mixture, and another flask which is 250 cm cube conical flask. 250 cm cube conical flask means maximum it can hold 250 cm cube. But when I add the same 60 cm cube, so it will have a lower depth. So when the solid will form, because there is a cross underneath, So when the solid or the precipitates are formed, because the depth at which the precipitate are formed is higher, so it will not allow light to pass through, so it will disappear in a short time. But if we use 250 cm cube, what will happen? The precipitate will form, but the height or the thickness of these precipitate is smaller compared to that which was formed in 200, which was formed in 100 cm cube flask. So that's why this will take relatively longer time for the precipitate to disappear. The formula for sodium thiosulfate is Na2S2O3, and formula for HCl, this is HCl. You can ask your question related to the topics which I am discussing so that it will clear your doubts as well. Because the main purpose of this is to clear your doubts related to the topic. So when we complete this, like example, if I say I have sodium thiosulfate is reacting with HCl, so what it result? It result in a formation of sodium chloride NaCl plus sulfur dioxide plus sulfur plus water molecule. This is aqueous, that's the gas, sulfur dioxide. But normally, because it is soluble, as the sulfur dioxide is soluble, so normally what happens that this sulfur dioxide mix with a water molecule and it will form sulfurous acid H2SO3. So normally we write H2SO3 NaCl plus S. But what is produced is this one. But because sulfur dioxide is soluble in water, so it will mix with water, form sulfurous acid. That's why normally you will find this equation is written. The why the solution turned cloudy or the precipitate form is because of sulfur. We can also measure the rate of the reaction by rather than solution will remain colorless, only the solid is formed, solid sulfur is formed, which will make a solution cloudy. This whole solution will not turn yellow because sulfur is yellow solid, but that is not dissolved in the solution. That is why we don't say solution turn yellow, we say a solid is formed or a precipitate is formed. So when we add acid using a thistle funnel, gradually acid poured reacted with metals give gas, and we collect that gas by using a gas syringe. Or what we can do, we can also react acid with metal or a solid with solution. A gas is given off. The purpose of the cotton wool that it does not allow the content of the flask to go out. Even for example, if there was no cotton wool, the gas will escape. So if the question is why a cotton wool is placed, it's to prevent the content in the flask to escape. And here we are measuring a change in the mass, the decrease in the mass, and here we are measuring the increase in volume. Then some of the reactions are affected by light intensity, which we are also called photochemical reaction, such as photosynthesis and photographic films. Not in a digital camera, the old cameras, it used a photographic plate was having silver bromide AgBr. So when it light falls on this metal, this will form a silver metal. So silver metal, the part where it is exposed to light, that will turn. If it is exposed too much light, then it will turn black. If it is lower light intensity, it will turn gray. And if it is not exposed to light, then it will remain as it is. So example, if I have a photographic plate and I covered this with a thick card, thin card, and no card, and I expose this photographic plate to light, what we will observe, the part which is not covered, the part which is exposed to light will turn black. Why turn black? Because silver ions from silver bromide in a silver bromide turn into silver atom, because silver bromide means it contains Ag and Br. So bromine will lose electron and silver will take that electron, so it will turn into silver metal. So silver ion turn into silver metal, that is a reduction, and bromide ion turn into bromine molecule, that is oxidation. So it's a redox reaction. Due to silver metal, it will turn black, and the part which is exposed to small amount of light will turn gray, because small amount of silver ion turned into silver atom, and the part which was exposed to uh, light but covered with a thick paper or thick sheet is not able light is not able to pass through. That's why it will remain as it is. The difference between cotton wool and plug or plug, basically, if we want to collect a gas, like we don't want the gas, we want the gas to escape at certain point, then we use this stopper. But if we want to keep the content and we want the gas to escape, we don't want to collect that, that's why we put a cotton wool. Yeah, that is how the black and white photographs are formed. The photographic plate itself is Ag, it's a layer, it's having a coating of silver bromide, it's AgBr. But what happened? So in AgBr, it contains silver ion and it contains bromide ions, because ionic compound. So when it is exposed to light, this is also a photochemical reaction. Silver ion turn into silver atom, and bromide ions turn into bromine molecule. So plus 1 changes to 0, that is reduction, and minus 1 change to 0, that is oxidation. So originally it is coated with AgBr. This is not used now. It was used in a photographic plates, uh, the cameras which were using the photographic film, but not now. Now it is not used in a digital photography. Because the silver is plus 1, the valency of silver is plus 1, so that's why it will form AgBr. And when you're asking a question, your question should be visible to everyone, so it's not an issue, because so everyone can understand what I'm trying to answer. I'm trying to answer your question, so when they read the question as well, so they identify like what is the main question and what I'm answering according to that. So it's better, like when it's good you're asking questions, so it should be visible to everyone. It will be beneficial for everyone as well, the question which you're asking. So that's a quick, like surface area increases the rate, temperature increases the rate, and if we want to calculate the rate of reaction, amount of reactant used over time, or amount of product divided by time. Then describe the application of a factor. If you remember, there was MCQs as well related to this part. Like dangers of explosive combustion with fine powder, such as in a flour mill or methane mines. So flour mills, the particles are very small, therefore surface area is large and could easily burn and cause an explosion. Due to these flames, the substance have a large flammable substances, they have the large area. And same thing, methane in the mine, increase in pressure, same as increasing the concentration, because in the mines the pressure is relatively higher as compared to normal atmospheric pressure. The particles are closer. So volume decrease, pressure increases or concentration increase, which increase the successful collision may leads to explosive reaction. You should be able to use your understanding and practical method which we use to calculate the rate or the speed of the reaction. We can measure the volume of gas, or we can measure the change in the mass with respect to time. Increasing temperature increase the rate, increasing concentration also increases the rate. How pressure increases the concentration, because what happened, this is for gases. Like example, if I have a container, so if I have a container and we have say 3 molecules or 4 molecules, when I increase the pressure, the number of the molecules here are not changing. But what happened, the space which the molecules are occupying, that will decrease. The same number of the molecules in a small space. So same number of molecule in a small space, what happened? Because we know pressure and volume are inversely proportional. If I increase the pressure, I reduces the volume, and concentration is moles by volume. The moles are not changing, but what happened? The volume decreases, so the concentration increases. So when I compare the concentration of gas in container A and container B, the concentration is high as compared to that in concentration as compared to container A. But both will lead to a same amount of product. In this chain, the amount of product will not change because the number of the particles are same. So you should be able to plan an experiment in which you work out which one is a better catalyst. So what you can do for this purpose, we normally use hydrogen peroxide. Hydrogen peroxide decompose by itself, not a stable compound. It can decompose into water and oxygen. So oxygen gas is there. So what we can do to find which is a better catalyst, so we'll take certain volume of hydrogen peroxide and we'll fill it with hydrogen peroxide. That's a solution liquid, and we can collect the gas say in 3 minutes or 5 minutes. Then we will repeat this procedure by adding a solid, which we assume that's a catalyst, and we'll measure the volume of a gas again in 5 minutes. But for a substance to be a catalyst, it should alter the rate of the reaction, it should speed up the rate of the reaction, as well as chemically it should not change. So how we'll conclude that chemically it does not change? We'll measure the mass before the experiment and after the experiment. So if the mass does not change and it affect the amount of a gas in a unit time or affect the rate, then it is a catalyst. So this was topic 7, chemical reactions. Any question related to this part? The hydrogen peroxide reaction is not a reversible reaction. If it was a reversible, then I should use two arrows. Like one is reactant form a product, product can decompose, form back the reactant. The water does not affect because the gas is given off. We are collecting the gas. Then reversible reaction means a reaction in which the reactant form a product and product can form back the reactant again. We call that as a reversible reaction. Like example, A plus B are the reactant and they're forming a product C. So A and B can form product C and C can decompose, form back A and B. We call that as reversible. And for reversible reaction, we define a term equilibrium. What is the meaning of equilibrium? It's always of 2 marks. What is the reason why 2 marks? You have one is for rate of forward equal to rate of backward, and the second one there is no change in concentration of reactant or product. So reactant product does not change their concentration and rates are equal. We call that as equilibrium. But if the rates are not equal, like example, if 2 grams of A and B are forming C, but at the same time only 0.5 gram of C is forming back A and B. So this is not in equilibrium. If it is not in equilibrium, then we'll use the term equilibrium is shifted. So where the equilibrium is shifted, right or left, which rate is faster? So equilibrium is shifted towards right because the forward reaction is faster. So the one which is faster, we call that as position or shifting of equilibrium. And shifting of equilibrium depends on different factors. It depends on addition of reactant or removal of product. If I add reactant or I remove product, then where the equilibrium will shift? Shifting of equilibrium. It's not about rate. Shifting. Adding a reactant or removing a product. Where the equilibrium shifts, right or left? In an equilibrium mixture, I add more reactant or I remove product, so equilibrium will shift towards right hand side. Same thing, if I add a product, addition of a product or removal of the reactant, then the equilibrium, the balance will shift towards left hand side. Same thing, if we increase the concentration, that is altering the concentration. Same way, if we increase the pressure in a gas, that's valid only for gases, the equilibrium will shift towards side where number of moles are less. And opposite will happen if we decrease pressure for gas. It will shift towards side where number of moles are more. So it's not left and right, it depends on what change we did. By example, we have nitrogen is reacting with 3 moles of ammonia, 3 moles of hydrogen to give 2 moles of ammonia. So when we check the number of the moles of a gas, if reactant is removed, this does not mean reactants are completely removed. We reduce the amount of reactant. And reversible reaction does not stop. Like for example, if I remove the reactant, say I was having ammonia, I remove nitrogen and hydrogen. So ammonia can decompose and form back that reactant again. Even I remove them completely, but ammonia will form those reactant back again. So for reversible reaction, that's why we call them as reversible. We can reach equilibrium from both sides if we have reactant or product. So here we have 4 moles of gas, 2 moles. So increasing our pressure shift the equilibrium towards side where number of moles are less. So it will shift on the right hand side in this example. And for temperature, it depends on what kind of reaction. Yeah, when we increase the temperature for endothermic reaction, it will shift to the left hand side. For exothermic reaction, it will shift to left, and for endo, it will shift to right when we are increasing a temperature, because it's about energy of the particle. Reactants have low energy and the product is having high energy in endothermic and opposite in exothermic. Then redox reaction. The term redox means in which there is a loss or gain of electron. So define oxidation and reduction. Oxidation you will define from oil, and reduction is from brick. But you can see they ask oxidation and reduction in terms of oxygen. So in terms of oxygen, what is the meaning of oxidation? Addition of oxygen is called oxidation, and removal of oxygen is called reduction. Like example, if I say I have iron oxide and I react with carbon monoxide, it form iron metal and carbon dioxide. Iron was having oxygen, but now there is no oxygen. So what is this change? Oxidation or reduction? Because oxygen is removed, so we call reduction. And carbon monoxide become carbon dioxide, so oxygen is added. So if oxygen is added, what we call this change? We call this change as oxidation. And for substance which reduction happen, that is an oxidant or oxidizing agent. And for substance which oxidation happen, that is a reductant or reducing agent. So if I say which one is oxidizing agent in this reaction, so iron oxide is an oxidizing agent or oxidant. And which one is a reducing agent? Carbon monoxide reduce to itself it is oxidized, but help in reduction of iron oxide. That's why it is a reducing agent. Then oxidation state limit to its use name as iron, like iron 2, iron 3. These are the oxidation state. So define redox in terms of electron transfer. Oil rig oxidation is loss of electron and reduction is gain of electron. Identify redox reaction by change in oxidation state by the color change involved when acidified potassium manganate and potassium iodide. Recall the equation involving, it means you don't have to learn the equation for this, but you should know the color change. So what will be the color change when potassium manganate is reduced? Mn7 is purple in color, but it changes into Mn2, so it will be colorless. Define oxidizing agent as a substance which oxidizes the other. Just now we discussed this part. And identify oxidizing agent and reducing agent from simple equation. From oxidation number, how we can identify? Because not all the reaction involve oxygen. Some of the reactions have different reagent. Like example, if I say you have copper sulfide, copper 2 sulfide reacted with magnesium, gives magnesium sulfide plus copper. So in this equation, we don't have any oxygen involved, so we cannot identify in terms of oxygen. Then the group number, using a group number, you will write the oxidation number. Group 1 plus 1, group 2 plus 2, group 3 plus 3, group 4 minus 4 or plus 4, group 5 minus 3, group 6 minus 2, group 7 minus 1, and group 8 is 0. When in a combined, when in elements, in a compound form, they have oxidation. In element, it's 0. So first I'll write for element, I'll write 0. Copper 2 sulfide, as I mentioned, so copper is plus 2. For transition element, their oxidation number, how you'll identify from the name, like they say copper 2 sulfide. And normally when you're taking in your course, you're taking copper 2 only. Copper can have plus 1 plus 2, but you're only studying most of the compound which are copper 2, but it can be other state as well. Magnesium is group 2, sulfur group 7. Potassium iodide color, potassium is +1, iodide is -1. So potassium iodide is colorless. When it form iodine molecule, then this iodine molecule may have different color depending on the medium. If it is in an aqueous, it is in water, it will be brown, if or yellow if it is dilute, and if in an organic solvent, it will be pink, and in the presence of the starch, it will be blue-black. So copper 2 changes to copper 0. So what is this change? +2 change to 0. So +2 change to 0 is reduction, and for magnesium 0 change to +2, that is oxidation. When do we add potassium iodide and when do we add potassium manganate KMnO4? Look, KMnO4, and normally it is used acidified because normal condition it does not work effectively. So it's always acidified potassium manganate. Look, in potassium manganate, potassium Mn, when it reacts, it changes to 2. So means itself it is reduced. So if substance is reduced, it is used as an oxidizing agent. So whenever I want to increase the oxidation number for any substance, I prefer to use potassium manganate or potassium dichromate or potassium chromate. But if I have potassium iodide, in potassium iodide, what happened when this react, iodide ion change to iodine molecule. So that is reduction, sorry, that is oxidation. -1 change to 0 is oxidation, or it is acting like a reducing agent. So if I want to reduce the substance, if I want to decrease the number, I will use potassium iodide because it's a reducer. So example, I have iron 3 and I want to change this iron 3 to iron 2. Which substance is useful here? Because I want to do reduction. I want to reduce. So which is a reducing agent? So Ki is a reducing agent. So in this reaction, what I should add? I should add potassium iodide. But example, I have iron 2 and I want to convert that iron 2 into iron 3. So which reagent? This is oxidation. So what I should add? I should add oxidizing agent. And oxidizing agent, I can add acidified potassium manganate to oxidize the substance, to increase the oxidation number. Is it clear? So this was topic 7, which is
Sir,
yes.
sorry for interrupting, but the color changes regarding the potassium,
Hmm.
like
For
it's going to be, yeah.
for potassium, there is no change color. The color is due to either manganate ion, which is, if you have potassium manganate, because Mn is +7, it is purple in color. But when it react, it form M. You are not learning equation, but it, when a reaction occur, it changes from +7 to +2. So that's why it is purple to colorless. And when we are using potassium iodide, iodide ion is colorless, but iodine molecule is brown or yellow. Brown in concentrated high concentration of iodine, and yellow in low concentration of iodine. So here it will change from colorless to yellow or brown.
In reducing reactions, right? In reactions
Yeah,
where something is reduced.
yeah, it
That's
is.
what I will write as an observation.
Yes, right.
Okay, so thank you.
So I'll share another link and continue this discussion.